our objective is to identify and define the reciprocal trig functions, okay? So to start off, I'd like you to do these warm-up questions. This is just 4 of them, and I'll come around and check your homework from Thursday night while you're doing that. Ready, set. Can someone give me an example of a reciprocal? Yeah, that's perfectly valid. 2 or 4, 4 over 2. Any other examples they want to throw out there? No, yes? Yeah, all did 2 over 4? Yeah? Yeah, 1/2 and 2. Right. That is what a lot of people usually pick. Yeah. Okay, so for number 2, if a reciprocal essentially flips a fraction, and sine is just sine over 1, right? It's just we don't write that every time. What is the reciprocal of sine? 1 over sine. I like the enthusiasm. All right. Okay, so we know that sine is the y over 1, or just y, right? In terms of y, what is the reciprocal of sine? So we just established that that's the reciprocal, but they want it in terms of y. What is it? So sine is y. So they're asking if sine is equal to y, how would you write it with y involved? Yeah, Chase. 1 over y, right? Because that's sine is equal to y. So it's 1 over y. All right, in this last little part, we should be getting pretty good at this. We've been doing it like crazy. What answer do I get for A? 2, yeah. Multiply top and bottom by 2 over 1, or just 2. Bottom cancels out, top. Multiply across the top and bottom, that's just 2. B, what did we get? There was a little more work involved with this one. Chase, what'd you get? Just square root of 2? Over 2. Yes, I agree with that. So let's walk through it really quick. Multiply the denominator by its reciprocal. You got to do it to the top too. You can't just do something to the bottom. You got to make it equivalent. So these cancel out. They all go to 1. Makes our whole denominator 1. We have the top though. But if you notice a little shortcut here, these 2's also cancel to 1. That's kind of nice. Because now you just have 1 times 1, which is 1, over 1 times square root of 2, which is square root of 2. But that is not valid. We know this. Square root of 2 over 2, like Chase said. Very good. Are we okay with all those? All right, moving on. This is the bulk of what is happening today. This is establishing those reciprocal trig functions. We know 3 out of 6. We are halfway there. It is not that scary, right? We're not scared of trig. Not scared of trig functions. We're good to go. Sine, what is our ratio for that? Do you remember, like the thing that we always start out writing? Yeah. Yep. Opposite over hypotenuse. This is like the 3rd time you've written this, so it shouldn't be like, whoa, what is that? We know that's the same as writing opposite over 1 because we're in the unit circle. Our hypotenuse, or our radius, is 1. Our opposite side of that triangle that we created, that special right triangle in the unit circle, what's the opposite side? It's the y, right? Yeah. Y over 1, or just y. This is cosecant cosecant. Cosecant, that is the reciprocal. Oh, well, if I could write it. Reciprocal of sine. All right? Sine, cosecant, reciprocal. So if cosecant is the reciprocal of sine, how would I start out? If cosecant is the reciprocal of sine, how would I start out? Okay, so I'm just going for maybe establishing how we do with our trig functions. Nicole, yeah? Yeah, hypotenuse over opposite. We know from our previously established sine that that's just 1 over opposite, or 1 over y, right? So sine and cosecant, those are reciprocal trig functions. Moving over to cosine, we know this one already too. We start out with adjacent over hypotenuse. We all know this. Easy peasy. All right. That's just adjacent over 1 or x over 1. Thank you. Or just x. Yep. Secant is the reciprocal of cosine. So if it's the reciprocal of cosine, we would start out flipping that first fraction, giving us 1 over x. So secant of some angle is just 1 over that x value. It's the reciprocal of cosine, which is just the x value. All right, jumping over to tangent. Opposite over adjacent, the TOA part of SOHCAHTOA. Opposite is what? Y. Yep. And adjacent is x. There you go. Yep. But we could also write this using our trig functions, right? Y over x, we could also write that as, what is that the same as? Using trig, well, what did, sine over cosine, exactly. Sine of t. Sometimes it's sine of theta, but you can really use any variable. Sine of t over cosine of t. Yep. All right, so you could probably guess by now this is the reciprocal of tangent. If it's the reciprocal, how do I start out? You can shout it out. Adjacent over opposite. Thank you, guys. Adjacent over opposite, which is also just x over y, or cosine, thank you, over sine. Very good. Are we okay with all of this? I want to do this for you. These, I'm highlighting these because these are the pieces of the ratio that we know, because we know the coordinates. We know x comma y, right? So we know how to find all of these if we know the coordinates, right? Yeah, we're good to go. Does anyone have any questions about these 6 trig functions and what their ratio is, how to find them? We're going to do an example together on the next page, if no one has any questions. All right, pi over 6. So the first thing that I think is really valuable to do, you don't have to do this, is to write the coordinate. If you have that, then you'll have x comma y right in front of you. What is our coordinate for pi over 6? The coordinate, like. Yeah, very nice. Yeah, that was great. All right, so we know sine is our y value, or y over 1. So what is our sine value? Sine of pi over 6. 1/2. Very good. All right, let's jump over to cosecant. We know that is 1 over y. Dan, do you know what cosecant is? You could just say 2. Yeah, it's going to be 2. He did this in his head, 1 over 1/2, which is just exactly like the warm-up, actually. Yes, you have a question? Yes, you could just flip it too. Right. You'll realize there's a lot of different ways to look at a lot of these problems, and some are quicker than others, and some maybe you took the long route, but that's okay as long as you can get to the answer. Cosine is just x, or x over 1, I should say, but reduces down to x. What's that? Norman, do you know what cosine of pi over 6 is? Cosine is just x over 1, or just x. Yes. Yeah, over 1, or just square root of 32. Very good, thank you. All right, jumping over to secant, which is 1 over x. 1 over x. Okay, so we could do 1 over this, right? 1 over square root of 3 over 2. But this is a little bit messy, right? Our bottom cancels to 1. That's the whole point of that. Top, you multiply across 1 times 2 is 2. Is that can I be done? Yes, no. You need to rationalize. Thank you. You were fighting with yourself there, Alex. Anytime there's a radical in the bottom, you are not done. You have to get that out of there. So we have 2 square roots of 3 over 3. Let's jump back over to tangent. Tangent is what in terms of x and y? Yeah. You just did y over x, which is, yeah, you are exactly correct. 1/2 over square root of 3 over 2. Let's clean this up a bit. Our bottom cancels, which is exactly what we want. We get that to 1. But we also have something very nice happen again, where these 2's go to 1 as well. So we're left with 1 over the square root of 3. But we are not done, as Chase reminded us in the last part. We are left with the square root of 3 over, we have to multiply the square root of 3 times the square root of 3, which is just, yeah, very good. You are. That was wonderful. All right, so why don't we take Alex's suggestion here. We have x over y. We have to flip that, so we could write square root of 3 over 2 over 1/2, or we could just do what? 3 over square root of 3, and then we only have a little bit of work to do. Square root of 3 times 3 on the top, all over 3, but that just gives us square root of 3. Make sure you always reduce. Are we clear on what's going on there? All right, let's move on. We don't have any questions. We're clear on how we're finding all these using our coordinates. All right, 5 pi over 4. What's our coordinate for that? Our coordinates for that? 5 pi over 4. You are exactly correct. Negative square root of 2 over 2, negative square root of 2 over 2. All right. So why don't you give those a try? we know this is y, 1 over y, x, 1 over x, y over x, and x over y. Remember, those aren't the only ways to look at it. Cotangent you could write as 1 over tangent also. So a lot of different ways to write these or see them. That's just in terms of x and y. So give those a try and we'll shout out the answers once I see people are done. Make sure you're simplifying and rationalizing the denominator while you're going through here. Okie dokie. Sine of t. What is sine of 5 pi over 4? Anyone can just shout it out, it's fine. Oh, yeah. That is correct. Negative square root of 2 over 2. Cosecant. Square root of 2. Almost. Negative, yeah. Negative square root of 2. You have to multiply top and bottom by the reciprocal and make sure it's the exact reciprocal that has the negative in it, and that's how you'll get that negative to follow through. What's our cosine of this angle? Yeah, you had it last time. Good job. All right. Okay, so what's this going to be? Is this, yeah. There we go, negative square root of 2. Yeah, you notice these are going to be the same because, well, the coordinates are the same. All right, tangent. We have y over x. That's negative square root of 2 over 2 over negative square root of 2 over 2. What's, yeah, 1. 2 over 2 is 1. 3 over 3 is 1. So negative square root of 2 over 2 over negative square root of 2 over 2 is 1. If I flip that, 1. Exactly. And the other thing that I mentioned in the other class is this is also just 1 over tangent, and we know tangent is 1. So you could also see it that way. Very good, guys. Very good. So I want you guys to, you can work with whoever's next to you, but I want you to do C and D. This is C, C and D. They should be pretty quick. And then I want to do E with you guys. So finish C and D, and then we'll talk about what our answers are, and then do E together. Beware of dividing by 0. Something over 0 can't happen in math. That's undefined. So beware of that happening here. Okay, so I see most people are done with C. So I'm going to go ahead. You can compare your answers with mine. The coordinate would be 1, 0. So sine is 0, which means cosine is 1 over 0. That's not allowed, so that is undefined. Cosine, that's 1. That's the x value, right? Secant, 1 over our x, right? Or 1 over 1. Just 1. Tangent is our y over our x. Our opposite over adjacent. 0 over 1, which is just 0. Cotangent, can someone tell me cotangent? Yeah, it's undefined again, because now we have x over y, which is just going to give us 1 over 0. And like Michael said, undefined. For D, we have pi. What are the coordinates for pi? Almost. -1. Yep. Don't forget those. All right. Can someone tell me sine? real quick. 0. Cosecant, undefined. What about cosine? -1, good. Secant, -1. Tangent, 0. And cotangent, undefined, good. Very good job, guys. All right, this last one, it's -pi/3. What should we probably do first? Coterminal angles, I like that, very nice. All right, so what should we add to it? 2 pi, right. 2 pi or 6 pi/3, right? Same thing. You see that? We have 2 pi, but we need to get common denominators, so we multiply top and bottom of this fraction by 3. That's how we got 6 pi/3. If you reduce that, it is 2 pi. That's how you can check that you're right. So, -pi plus 6 pi. How many pi's are left? 5 pi. All right, do we know what our coordinates for that one? Wow, very nice. That was immediate. Oh, well. Oh, okay, good. That's what I like to hear. All right, so our y is -√3/2. Yeah? Okay. Cosecant, this one's a little messy. 1 over our y, which is 1 over all this business. We're going to clean this business up. Multiply by the reciprocal, so that is -2 over √3. That negative has to come with, or else you'll have a negative left on the bottom. The whole point is to get the bottom to go to 1. Do the same to the top, -2 over √3. So all this cancels. That's good news. Left with -2√3. Can't leave it like that. Chase told us that earlier. So we have when we rationalize the denominator, -2 times √3 over 3. Do we agree? What is our cosine? 1/2. So what does that make our secant? 2. Flip it right on over. All right, tangent. Tangent, that's a little messy. Tangent is y over x. Right? That's what it is. But we have to clean it up. Multiply both top and bottom by 2. This is nice though because we do have some cancellation here. Oh, see, look, that wasn't too bad. Not too bad. You getting good with the crazy fractions? Yeah? Yes. Where are you looking? Tangent. This is y over x, and then it's -√3 over 2 all over 1 over 2. √3. Because we have this negative in front here, so that has to come through. So cotangent, we could do x over y and write this all out, or we could do 1 over tangent. What would you prefer? Me too. I would prefer 1 over tangent also. So that's just 1 over -√3. Clean that up a bit. Multiply top and bottom by √3. Square root of 3. And we have -3. So our final answer for cotangent is square root of 3 over -3. Does that make sense to everyone how we're doing this, how we're using our coordinates, using our x and y to find all of these trig functions? Because now we know what they mean. in terms of sine, cosine, and tangent, right? Makes sense? Are there any questions? Any confusion anywhere? The next thing you have to do are these conclusion questions. You can get started on those. We will finish that up as a warm-up. The other thing that you could do is start on your homework. Your homework is the last 3 pages in your packet. It looks long because you're doing all 6 of the trig functions, but it's not that. There's not that many questions. You just have to do all 6 of the trig functions for each of them. And you saw how quick that went. So you have these 3 pages in the packet, and according to your agenda, you also have 3 problems in your book. Okay? So come in tomorrow with the worksheet in the packet done and the 3 problems from the book done. If you have some extra time, sure, do the conclusion questions, but I will open the class tomorrow giving you an opportunity to do those. So if you want to get ahead of the game, that's fine. Are we clear on what we're doing right now? Maybe starting on our homework or working on the conclusion questions. All right, cool beans.